Let's do a tutorial for triple definite integral equation. Example number 1. Triple integral of x plus y plus z dz dy and dx. We have three integral signs here, and therefore it is a triple definite integral equation with respect to z, y and x. And one thing you have to remember, that you can take the given function with respect to z first and then y and then x. You can change the order of integration. Like for instance, we have the first integration with respect to z. If you remember in the previous example that we did in the single definite integral equation and double definite integral equation, normally we took the first integration with respect to x, but it doesn't matter. It's not compulsory that you must take x. You can take z, you can take y, you can change the order. It's not an issue. Like the first integration here is with respect to z, but the limit must be other than z. If the limits are in variables, they must be other than z, like we have here from 0 to x minus y. Now this thing you must remember. The second one is with respect to y, and the third one is with respect to x. Solution. Now integrate the given function x plus y plus z first with respect to z, and after integration we have x times z plus y times z plus z squared over 2. Substitute the value of the limits in z variable. Our upper limit is x minus y and the lower limit is 0. The integration was with respect to z, and therefore you must substitute the value of limit in z variable, not in xy variable. This term will be 0, and we're left with the double integral of 3x squared minus y squared minus 2 times xy dy dx. We just took 2 outside of the integration. And now take the second integration. Whatever result you achieved from the first integration, you just simply integrate it with respect to y. And after integration we have now 1 over 2 times integral of 3 times x squared times y minus y cubed over 3 minus 2 times x times y squared over 2. Substitute the value of limits here. Our upper limit is 1 and the lower limit is 0. Again remember, the integration was with respect to y, and therefore you must substitute the value of limits in y variable, not in x and z. This will be 0, and we're left with the integral of 3x squared minus 1 over 3 minus 2 times x times 1 over 2. Now take the last integration. Just integrate the final value with respect to x. After integration we have 1 over 2 times 3 times x cubed over 3 minus 1 over 3 times x minus x squared over 2. Substitute the value of limits here. Our upper limit is 1 and the lower limit is 0. Since we have taken it with respect to x, and therefore substitute the values of limits in x variables, this term becomes 0, and we're left with 1 over 2. Here is the final answer for the given function. Triple definite integral equation. Example number 2. Triple integral of x times y times z dz dy and dx. We have three integral signs, and therefore it is a triple definite integral equation. When you look to the first integration, again, it has been taken with respect to z first. You can change the order anytime. You can put dy first or dx first, whatever. It's up to you. But the limits must be other than z. The second one is with respect to y, and the third one is with respect to x. Solution. Integrate the given function with respect to z first. After integration, we have x times y times z squared over 2. Substitute the value of limits in z variable. The upper limit is 2 and the lower limit is x squared plus y squared under the root. We have taken it with respect to z, so you have to put the values in z variables. Sort it further, and we got 1/2 times double integral of 4xy minus y times x cubed plus x times y cubed dy dx. We just took 2 common and brought it outside of the integration. Now take the second integration and integrate the final value with respect to y. After integration, we have 4 times x times y squared over 2 minus y squared over 2 times x cubed minus x times y to the 4 over 4. Substitute the value of limits here in y variables. The upper limit is 1 and the lower limit is 0. This will be 0, and we're left with 8x minus 2 times x cubed minus x dx. Now take the third integral and differentiate the final result with respect to x. After integration, we have 1/8 times x squared over 2 minus 2 times x to the 4 over 4 minus x squared over 2. Substitute the value of limits here. The upper limit is 1 and the lower limit is 0. Substitute these values in x variables. This will be 0, and we're left with the final result, which is 3/8. This is the final result for the given function.